Welcome to Module 5, describing angle pair relationships. There are a couple of very important types of angles in geometry, complementary angles and supplementary angles. And sometimes people get these mixed up, but the main thing is complementary angles are two angles whose sum is 90 degrees. Supplementary angles sum to 180 degrees. When you have two adjacent angles, think of adjacent as being like the adjacent house or an adjacent student. Now, all adjacent is a fancy name for is next to. So if two angles are next to each other, they are going to share a common vertex and side. That's the main thing, common vertex and side. So sketch examples of complementary angles. Here we have an adjacent pair which actually shares a common vertex here, and they are adjacent because, again, common vertex and common ray for the vertex. 25 degrees and 65 degrees add up to 90 degrees, so they are complementary. Non-adjacent, they're not touching, as you can see here, so those would be non-adjacent angles. Sketch examples of supplementary angles. Adjacent, just think of adjacent supplementary angles as like a line with a ray coming out of it. So here's your line, and you have just kind of a random ray coming out of it. 50 degrees, 130 degrees is one example. There are many more, obviously. And here's an example of non-adjacent because they are not next to each other, not sharing a ray or side, and or a common vertex. So it says, identify components and supplements. Directed example. What are some complementary angles that are within this figure? Well, again, complementary angles, they don't have to be adjacent, they don't have to be next to each other, but they have to sum to 180 or to 90 degrees. So angle BAC is 32 degrees and angle RST is 58 degrees. If you add those together, you will get 90 degrees. Supplementary angles, we have CAD and RST. Again, CAD is 122 degrees and RST is 58 degrees. You sum them together and you get 180 degrees, which are supplementary. Now, which one of these angles is adjacent? Or which set of angles is adjacent? Well, the only one that's adjacent is the one that shares the common side and vertex, which would be angle BAC, which is this guy here, and angle CAD, which again is this guy here. So those are your adjacent angles. Okay, so we have find the measures of complements and supplements. In model example 1, you have given that angle 1 is a complement of angle 2. That's the key word there is complement. Angle 2 you have to find. If we know the measure of angle 1 is 68 degrees, since complementary angles add up to 90, you just do 90 minus 68, which gives you 22 degrees, and that's measure 2's angle. In the guided example, you have given that angle 3 is a supplement of angle 4, and the measure of angle 4 is 56 degrees. Again, we have supplement as the key word. That means it adds up to 180 degrees. So all you do is 180 minus 56 gives you 124. In the directed example, you're asked to find both the complement and the supplement. So all you have to do is you just have to basically make sure that you keep them straight. The complement is 90 degrees minus the angle, which would be 43 degrees in this case. The supplement would be 180 degrees minus the angle, which would be 133 degrees. Example 3, finding measures. If we have a golf club forms a pair of supplementary angles with the ground, find the measure of angle BCE and the measure of angle ECD. So we have these two algebraic expressions. The mistake that I see a lot of people do is they take these two and they set them equal to each other. Again, in the directions it says they are supplementary angles. So that means their sum is going to be 180 degrees. So you set up the algebraic equation 4x plus 8 plus x plus 2 equals 180 degrees. Once you have this set up, you solve for x, and then you have to find BCE's angle and ECD's angle. So you have to take the value of x and plug it in for each value of x that you see in the problem. So when we do that, we multiply, we get 144 degrees and 36 degrees respectively. Okay, so directed example, angle LMN and angle PRQ are complementary. Find the measure of the angles if we know that LMN's angle is 4x minus 2, and the measure of angle PQR's angle is 9x plus 1. They're complementary. They tell us they're complementary in the directions, so all you do, since they're complementary, you add them together and set them equal to 90 degrees. Collect your like terms, solve it algebraically, and you should get x is equal to 7. When you know x is equal to 7, you're trying to find the measures of the angles. Again, you're going to substitute your x value into each one. And watch your arithmetic here. And once you do that, you get 26 degrees for LMN, and PQR is going to be 64 degrees. Some other special types of angles, we have a linear pair and vertical pair. In a linear pair, think of a linear pair, the root of this is line. Line measures up to 180 degrees. So within the linear pair, you're going to have a line. And just think of a line and then a ray coming out from that line. They have to be adjacent angles. So for example, this would not be a linear pair. In a vertical pair, this is a part where people have a little bit of trouble visualizing it. But in a vertical pair, think of like two pencils intersecting to form an X. You can't have, like for example, in a non-vertical pair, this ray here and this ray here, you have four completely different rays, or non-opposite rays. But here you have two lines that are intersecting to form an X. And if that's the case, that means angle 7 and angle 6 are going to be a linear pair, or I'm sorry, a vertical pair. Angles 8 and angles 5 are going to be a vertical pair because they're opposites. Now, what about the definition? In your own words, write a definition of linear pair of angles. So, linear pair of angles, they have to be adjacent and supplementary angles whose non-common sides are going to be opposite rays. That's why they form a line here. A vertical pair, two angles whose sides form two pairs of opposite rays. Again, opposite rays. In this one here, they form two pairs of opposite rays. This one here, you don't have any opposite rays. You have multiple rays, but no opposite rays. The key is opposite. So in this guided example, it's asking you to identify all of the linear pairs and then identify all of the vertical angles. Well, common thing, what I look for is I look for where's my straight line. Well, I have a straight line right here. And I also have a straight line in another place, but I'm going to look at this straight line. If I look at the top here, I have three angles that make a line. Absolutely. But I'm asking for linear pairs. Pairs meaning two. So it can't be angles 1 and 2 and 3. What it can be is it can be angles 4 and 5, because again you have this line here and then a ray that's coming out from here. So angle 4 and angle 5 would form a linear pair. Now, if I erase all this, let's say I want to find the other line. Well, the other line in this figure is this guy right here. And again, I have angle 2, 3, and 5. They all make up a line. If you add those all together, they'll be supplementary. The only other linear pair that I see is angles 1 and angles 4. So those are my linear pairs, angle 1 and 4 and angle 5 and 4. Now for vertical, you're going to look for, again, look for the X. So I'm looking for an X. The only place that I see an X here is this line. Wow, and this line here. So if I do that, let's see if I can do that a little bit better. If I look at this x, I'm going to try and see, because vertical pairs have to be opposite each other. So the only numbers that I see are opposite each other are going to be angle 1 and angle 5. Now this takes it up a little bit in terms of difficulty, because now we're going to put word problems, algebraic word problems, and you have to construct a figure that is associated with these algebraic word problems. So, it said find the angle measures. Two angles form a linear pair. The measure of one of the angles is 5 times the measure of the other. Find the measure of each angle. Well, if we know that two angles form a linear pair, draw a linear pair immediately. You don't have to label it, just visualize it. The measure of one of the angles is 5 times the measure of the other. So I'm going to call the smaller one x. That means if the other one is 5 times the measure, that means this is going to be 5x. And if we know that these two are a linear pair, we can add them together and say 5x plus x equals 180 degrees. Once we solve, we get x is equal to 30. We know that the smaller angle is 30, but we also have to find the larger angle, so we're going to plug this back in here, and we get 150. In the directed example, it says the measure of an angle is twice the measure of its complement. That means you have a right angle. So, immediately draw a right angle. When you do that, here's your angle, and then you have just a ray coming out of the middle of the angle. Find the measure of each angle. Label what you know. If we know the twice part here, again the smaller one, just like in the previous problem, is going to be x. The larger one's going to be twice that, which would be 2x. Since they're complementary, they add to 90 degrees. You add them up, set them equal to 90, and solve for x. Once you solve for x, plug each one in to solve and find out the measures of each of the angles.